Thank you for joining us for the Redpanda Serverless demo today. Real quick, the things that we're going to cover are just uh, creating a cluster, walking through some of the basic facilities that are available to you in Redpanda Serverless, and then I'm going to hand it over to Craig, and Craig is going to be the guy who walks through the a little bit more of a use case in a real world scenario, and it's going to use Redpanda Connect and show how we can bring you value very, very quickly. So to get started, I'm just going to show you how easy cluster creation is, right? You can see I'm in our cloud interface here. Here's a list of the other clusters that are available in my little namespace. But emphasis on how quickly I can create a serverless cluster. I click create, I click create again. We give our cluster a name. Uh, And I'm just pointing out the namespace that it's in, what cloud provider we're going to put it in. We have GCP and Azure coming soon, so you'll see little boxes for them. And I'm going to grab US East 1 as my region. And that's all it took to create a serverless cluster. Demo over. See you guys. Bye. Just kidding. So what you see here is the initial kind of landing overview page for your cluster. You've got a couple of little kind of hello world examples that you can get started with. If you've already got some code written or you want some example code, you can go to the Kafka API section. You'll get your little Bootstrap URL there, and you can go and put that into your client, any Kafka client, and get started. As you can see, there's some other little code examples and stuff like that here, which are pretty cool. On top of that, this is also where you would go to get your access to the schema registry. And so if you're going to use a schema registry, like if you're going to use JSON schema or protobuf or Avro, this is where you'll get started there. Uh, just off the top, here's the list there's the empty list of topics that we have. From here, I could go and, create a real basic topic and assign it a number of partitions, say how long I'd like to hang on to this data for, and create my topic real simply. Um, what I think we'll do is let's switch over to the cluster that Craig's going to use, right? That was us just building a cluster real quick. Let's switch over to the cluster that Craig's going to use for the demo. And one of the reasons that I'm going to do this is I just want you to see a little bit more of the interface, right? Here's the topics, but here's an actual topic with actual data in it. And a lot of customers get a ton of value out of the Redpanda GUI for this reason, is the ability to go in and actually I can look at an individual message and see, hey, here's what partition this is on. Here's what its offset number is. It's JSON. Here's what compression we're using. If we're applying a schema, it would show you and also deserialize the data so that you can see it here. It's a really good troubleshooting tool. There's a great experience, for developers as well as operations people, stuff like that. The other thing that I think we should probably just look at quickly before I turn it over to Craig is we're going to look at security. And from here, this is just the SASL Scram users that you create. We have normal, SHA-256 and 512 authentication. You can just create your user here, and once that user is created, they've got a password, you can connect, but they don't have any permissions. So you'd go in here and create an ACL for user face, and we can maybe give them access to a specific topic. And let's say we want them to be able to perform all actions on that topic, or we can get a lot more granular if we want. Let's just create that user. And now when we connect to this cluster with this user, they will have access to that topic and all the actions, right, that are associated with that particular group. Uh, I think that's mostly what I wanted to cover, just with regards to some of the basics about a serverless cluster, emphasis on just how easy all of this is to do. We also have Terraform that would allow you to create these clusters and manage them as well. So lightweight, simple, easy to use. That's what we're really focused on in our serverless components. We've got a big list of other, full-blown deployment types that you can have on dedicated hardware and things like that. But I also just wanted to swing by our calculator. So if you're wondering, is serverless right for me? Or should I consider maybe a larger solution? Or just in general, how do the costs break down for serverless? We have a little calculator online here. You'll see if you click bring your own cloud, that's one of our popular deployment types. Really what we'll do is, schedule a call and give you a quote. But on the serverless side, you can choose your cloud provider, you can choose your region, you can select some type of a workflow and get a real basic idea for the cost of your for the cost of that cluster, right? So if you have an idea of, a megabyte per second in, or maybe 2 megs out, how long you want to retain that data, number of partitions, that's what drives the number here that's running the calculator. And of course, if you are capable of doing an annual commit, first of all, you can come down here and just fill out your basic information. Annual commits come with not only discounts, but also support, which I think is pretty important. So, uh, thank you, and I'm going to turn it over to Craig for the rest of the demo and the kind of end-to-end use case using Redpanda Connect. Take it away, Craig.
Cool. Thanks, Brian. As Brian alluded, I am in fact the guy who is going to show you the Redpanda Connect interface on serverless. What we're going to do is take a crypto endpoint that returns a bunch of tickers, and we're going to stream that into Snowflake in real time. So that's pretty cool. The first thing I'll do is I'll actually show you what that endpoint looks like. So if you can see my terminal window, we're going to curl the CoinLore endpoint, and it's going to return. We'll pretty print it. It returns a whole bunch of tickers, many tickers, in fact. So many tickers. But the payload is sort of wrapped with this data wrapper, and it comes back in an array, which means that if whenever I call this API, I'm going to get one response back instead of a bunch of responses for each ticker. So we're going to have to deal with that whenever we actually process this data. All right. So switching back to my actual Redpanda window. There we go. I did it. So clearly serverless is easier than sharing a screen on Zoom. We've proved this beyond a shadow of a doubt. So Brian showed you the interface for this cluster. We didn't really touch on the Connect tab, which is where you will create and manage your Redpanda Connect pipelines. Here you can see I've got two pipelines. And let's look at the first one, which is the CoinLore ticker polling. This is where I'm actually going to call the API. And I've already got the pipeline built out. There's really just a couple sections. The first piece is the input, where we're going to use the HTTP client input, and we're going to call that same CoinLore endpoint that I just showed you on my terminal window. And we're going to put a couple parameters around it to get call. We're going to time out after 5 seconds. Most of these things are just boilerplate type things to call an endpoint. We're going to rate limit it, which isn't necessarily required, but sort of kind of just flexing on some of the features of Redpanda Connect. We're going to run it once every 5 minutes. We could run it much more frequently than that. I don't know, the API provider might not like me calling it more than that, but that's between them and their internet provider. We can also do some pipeline processing. So I mentioned that that payload came back was like one response with all those tickers buried in the array. What I want is a single message for each ticker. So what we're going to do is do a little bit of mapping in what we call bloblang within Redpanda Connect. And the first step is to basically extract everything out of the data object. Remember, everything was wrapped with that data wrapper. And so we're going to pull everything out one layer and just get to the array that's underneath. And then we're going to use this unarchive processor, and we're going to format as JSON. So we're going to take all those JSON objects that are inside that array and turn those into individual messages that we're going to feed into the next stage of the output, which in this case, we're using the Kafka Franz output, which is just a way to write to Kafka topics, or in our case, Redpanda topics. We had to you tell it a couple things. It's just like any other producer where you'd need to tell it, your broker endpoints, the topic you want to you want to produce to, any sort of authentication. Now, Redpanda Connect within serverless is really cool. I don't need to like remember what my broker endpoint is. We've got built-in environment variables that allow us to point directly to those things without knowing. And this makes it more portable, right? So I could have this on a test environment and get my pipeline working and then push it to my production environment and not have to rechange my endpoint, things like that. I've also I've uh, looked at the payload itself here, and I've taken this is the document that we're operating on. I'm looking at this symbol field, and I'm going to turn it into the message key so we can our messages will actually be keyed when we produce them. And then security. So on serverless and BYOC, all the Redpanda cloud products, TLS is enabled by default. You can't even turn it off. Yeah, security by default. There's no way around it. You have to be secure. And then our users, Bryan showed you how he created a SASL user. Here's how we're going to specify the actual credentials. So my user was the crypto user. SHA-256 is the method, but the password you'll see is buried in this secrets thing. So obviously, I mean, I could have typed my password in plain text here, but that's probably not what you want to do. So we've actually got the concept of secret store, where you can bury secrets within your serverless instance here, so you don't have to hard code secure pieces of information. So in this case, I've got my SASL password, and we can try to look at it, but it won't show it to me. I don't think. Nope. Just making sure. It's very easy to create a new secret. And then underscores only. Create the secret, and then we'll be able to immediately use it in our Connect pipeline. So if I wanted to inject a secret there, I could edit my pipeline, and I could do a quick secret add, secret face, and there, now I've injected into my pipeline. Of course, this is nonsensical syntax, but the point is how easy it is to add that secret. So we'll cancel that update. And see that pipeline is already running. Great. So what that is doing is pushing messages into our Kafka topic. The topic was, of course, crypto data. So let's go over and look at topics. Bryan sort of hinted at this. You can see here, it is 12:51 Central Time on my computer. You can see this was just mere seconds ago. This was inserted in the topic. And you can drill in. You can see the actual pieces of the payload, all the JSON elements, the fact that it was the key was virtual. That was, I guess, the ticker that we used. Symbol virtual. So that's how we built the key into that. And you can also do things in here like push down filters to filter for just specific messages. But anyway, that's how quickly we were able to get from an API endpoint pushing into a Redpanda topic. But that's only really half of the coolness that we can do. The other piece is once I've got it in a Redpanda topic, I want to stream that to something like Snowflake. So we're going to use our Snowflake connector to get that data from Redpanda into Snowflake in real time. So once again, I've got a new pipeline called Stream to Snowflake, where the input is now the Kafka franz. We're going to read from, instead of before I was pushing to, now I'm consuming from a topic. Again, I give it my topic name, the environment variable for the brokers, all my credentials, and just for fun, I added a little bit of pipeline processing here. I added the timestamp to to each message. So there might have been a timestamp attached to the ticker quote itself. Well, I'm going to add another timestamp of when I processed it, and it's that's that simple. And then on the output side, we're going to use the Snowflake streaming output. You have to give it a bunch of information about your Snowflake implementation, and you have to give it again a key. Snowflake requires a private key authentication, so we embed that with another secret. So really, just a couple lines of YAML, and we were able to stream data over to Snowflake. All right, now here we are in the Snowflake interface where the data was streaming in. You can see I've got a table called CoinLore Raw where I'm pushing data in to all these columns that match the payload of that API input. And I'll quickly query it. We can see that's what that raw data looks like. Now, if we were to run a little quick count on this, you could see that the count is increasing. And with any luck, we can catch this on the boundary of when the last one ran, when the next one's going to run. We can see the count increase. But unfortunately, it's not running frequently enough to make that abundantly obvious. But because you can do any sort of SQL analysis you want because it's Snowflake and Snowflake likes queries. But I don't mean for this to be a SQL tutorial. But this particular query, returning results for Solana ordered by time. Of course, you can do anything you want with this data once you've got it into Snowflake. That's the beauty of Snowflake. So, without further ado, this was the ease of creating a pipeline from a crypto endpoint, pushing all the way to Snowflake in real time with just a little bit of YAML, not anything super complex. And I would argue that it's in fact easier than sharing a Zoom window. So, thanks everyone.